The T-1 computer uses both electrical and pneumatic power to operate. Here you can see the 27 volt DC input on this end, and over here at the lower aspect you can see the 60 pound per square inch air pressure that is used to drive the bellows and make the bomb sight function. Just above that you can see the pitot and static ports. The pitot to have air pressure to simulate airspeed, and the static to drive both airspeed and altimeter. This is the course knob. This would be altered by a remote course knob or a remote compass. However, we can also alter that by manipulating the course turn knob here on this end, and this changes the course heading of the bomb sight. This is the wind direction knob, and below it we have the wind speed knob, and both of these play into the drift function. This is the terminal velocity knob, which sets the terminal velocity of the bomb, which is different than the time of fall input used for the Norden and Sperry bomb sight. This is our airspeed indicator, and this is an odometer which told the technician that the airspeed indicator was correctly calibrated, and at an airspeed of 200 miles per hour this should read approximately 177. Over here we see the height above target dial, which is essentially an altimeter, and it had its own odometer, and when this was set at 5,000 feet the odometer generally read about 35.5. Below you can see the all-important drop angle indicator, and this would change based on all the various inputs with airspeed, ground speed, headwind, and altitude above target. This knob set the height above target. So if the target was elevated above the ground, that would be added into or subtracted from the height above target dial. And here's where we set the barometric pressure of the target. This little bubble would be set to level, and this is where the gyroscope would interact with the drop angle indicator so that the airplane could drop bombs in a climb or a dive. When we come around over here on this side, we see the pneumatic function and the bellows that operate the bomb sight. Each of these bellows received air pressure or decreased pressure from the static port, and as these inflated and deflated, they would alter a blade which was located in between two jets. This is the airspeed on the right and the altitude on the left. And you can see that as these bellows expanded and contracted, they would shift this small blade. It's very difficult to see, but there are two air jets blowing that 60 pound per square inch air across from one to the other. And as this blade would descend and rise, it would alternately interrupt the airflow between those jets. And you can see that there is a curved angle on the blade, so that as the airspeed and other parts of the bomb sight move to the left or the right, it would change its interaction with the blade. These are the other small bellows that would be powered as this moved up and down and alternately interrupted the air supply. As the airspeed sector moved to the right, you can see that the curve of the blade changed its interaction. These small bellows located throughout would be affected by the air pressure, and they would alter the interaction of these bobbins with the motors as the motors rotated. You can see here one motor rotating and how these little bobbins would spin, and there's one on either end of this servo motor. And as the bellows inflated and deflated, they moved the bobbin to the left or the right so that a different side of the bobbin would interact with the servo motor and reverse course back and forth as it was moved with the blade interrupting the jet flow. So there was an equilibrium reached as the bellows went up and down that caused the bobbins to choose one direction or the other and go back and forth. This is the other side of the gyroscope, which also would interrupt an air supply and alter the drop angle depending on a climb or a dive. Here we see the bomb sight turned on and working, and you can hear the different parts of the bomb sight reaching equilibrium and hunting. Here is the gyroscope starting to stabilize. And the drift knob is hunting back and forth. We're going to bring the airspeed up to 200 knots. By increasing the pitot pressure. And now you can see that with the airspeed at 200 knots, we're reading approximately 178 on the counter. And you can also see that our drop angle has changed considerably. We're going to next bring the height above target knob up to about 5,000 feet. And you can see we're reading about 35.5 there and about 178 there, which means the bomb sight is calibrated correctly. And our drop angle has changed again with the increasing height of our target. Here you see as we lift the bomb sight and change the angle, the drift angle also changes. Now we'll add in some wind from 90 degrees off to one side. And you'll see that as we add wind speed, the drift shaft will start to rotate.